Hello friends, welcome to the session on microprocessor 8085. In this session, we'll be discussing about 8085 machine control instructions. In this session, we will discuss what we mean by machine control instructions, what are the operations that can be performed by using these instructions, how to write them, and what exactly happens when these instructions are executed. Friends, as you know that you are viewing this session on my YouTube channel, and this channel is being designed so that you can learn by sitting at your home only during this pandemic session. So you can watch many more educational videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question what we mean by the machine control instructions for the microprocessor 8085. We know that 8085 is a very popular microprocessor, and this is the simplest type of the microprocessor. By using this microprocessor, it is possible that we can design some microprocessor based system. And whenever we want to make use of this microprocessor, then it is necessary to feed the instruction to the microprocessor. The instructions can be classified into different categories such as data transfer instruction, arithmetic instruction, logical instruction, branching instruction, and finally the control instructions. Now, already we have discussed the four different types of instructions, and this is the session in which we will discuss what we mean by the machine control instructions. So instruction is a binary pattern, and instruction, whenever it is fed to the computer system or it is fed to the microprocessor based system, then it will perform the specific function. 8085 has a lot many instructions. Machine control instructions are the specific instructions that can perform the tasks such as stack manipulation, stack memory manipulation. Then it can alter the internal control flags, and also these instructions are used to read the input data or to write into the output port. There are different machine control instructions. So for example, we can have the instructions such as push data, where the data is being shifted into the stack memory. Whenever we want to read the data from the stack memory, then we can make the use of the instruction pop data, where the data from the stack is being called. We can have the instructions such as XTHL, where the top of the stack is being exchanged with the content of the register pair HL. We have the instruction to read the data from the input port into the accumulator. And for this, we will make the use of the instruction in data. Whenever we move the data from the accumulator to the output port, then we can make the use of the instructions such as out data. And whenever we want to stop the processing of our assembly language program, then we can make the use of the instruction halt, where the microprocessor 8085 will be stopped. So let us understand one by one how to write these instructions. So the first instruction that we are going to discuss is the push instruction. Push followed by RP, that is the register pair. The name of this instruction is push, and whenever this instruction is executed by the microprocessor 8085, then the content of the higher order of the register pair RP, that is RH, will be moved to the memory location whose address is one less than the content of the stack pointer, and the lower order of the register pair, that is RL, will be moved to the two less than the content of the stack pointer. And also you will find that the content of the stack pointer will be decremented by 2. So for example, we can write the instructions such as push B, where the content of the register pair will be shifted to the stack. So this instruction is a 1 byte instruction. Another instruction that is being used quite frequently while writing the assembly language program is the push processor status word, or push PSW. Now in this instruction, one can easily observe that the content of the accumulator will be shifted to the location whose address is one less than the content of the stack pointer. And then the contents of the condition flags such as carry, parity, auxiliary carry, zero, and sign flag, they are being assembled into the processor status word, and this word is moved to the memory location whose address is 2 less than the content of the stack pointer SP. And therefore the carry bit will be shifted to the 0th position, SP minus 2, parity bit will be shifted, auxiliary carry bit will be shifted, 0 bit will be shifted, and then these 3 bits are undefined, and then the sign bit will be shifted to the most significant bit position, so that the processor status word or PSW will be assembled. And then the content of the stack pointer will be decremented by 2. So the addressing that is being used in this instruction is the register indirect addressing. Now, another instruction that is being used is the pop instruction, pop followed by the register pair RP. Now, in this instruction, the content of the stack pointer, the content of the memory location whose address is being specified by the content of the stack pointer is being shifted to the lower order register of the register pair, that is RL, and the content of the next location will be shifted to the higher order register of the register pair RP, and the content of the stack pointer will be incremented by 2. So this instruction is also a 1 byte instruction, and it can be written such as pop B. Also, we can have the instruction for processor status word pop PSW, where the content of the location whose address is given in the stack pointer is being shifted to the carry flag. The next bit is being shifted to the parity flag. The bit number 4 is being shifted to the auxiliary carry flag. The bit number 6 is being shifted to the 0 flag, and the bit number 7 is being shifted to the sign flag. And also the content of the memory location whose address is specified by the stack pointer plus 1 is being shifted to the accumulator, and the content of the stack pointer are being incremented by 2. So this instruction is also a 1 byte instruction. So one can easily observe that in these instructions, either we are changing the content of the stack pointer, or we are moving the content of the memory location pointed by the stack pointer, and therefore these instructions are being called as the machine level instructions. Another instruction that is being used is the XTHL, that is exchange stack top with H and L, that is the content of the memory location pointed by the content of the stack pointer is being exchanged with the content of the register L, and the content of the next location is being exchanged with the content of the register H. So this is the instruction that is being used for the exchange of the stack top with the content of the register pair H and L. There is another instruction that is being used, and this instruction is SPHL, that is move HL to the SP. That is the content of the register H and L are moved to the stack pointer SP. So this instruction is a 1 byte instruction, and this instruction can be used for the initialization of the stack pointer SP. Now, whenever we want to read the data from some input port, then we can make the use of the instruction in port, where the data is being placed on the 8-bit bidirectional data bus by the specified port is being moved to the register A. Say, for example, when we write the instructions such as in10H, where 10H is the port address. Then the data placed by this port is being moved into the accumulator. And this instruction is a 2-byte instruction. So this instruction is used whenever we want to read the data from the input port. That is whenever we perform some interfacing with the microprocessor 8085, then in that case, we can make the use of such instruction while writing the assembly language programs. This is the instruction output. This is an output instruction where the content of the register A is being placed on the 8-bit bidirectional data bus for the transmission to the specified port. And this instruction is being written as out 11H. Say, for example, 11 is the address of the output port. So the content of the accumulator will be moved to the port 11. So this instruction is also useful whenever we write assembly language program to output the data from the accumulator to the specified port. Another instructions that are useful is the enable interrupt. This interrupt system is being enabled through this instruction. So interrupts are recognized during the interrupt enable instruction, and this instruction is a 1-byte instruction. If you want to disable the interrupts, then you can make the use of the instructions such as DI, where the interrupt system is disabled immediately following the execution of the instruction DI. This is also a 1-byte instruction. Whenever you want to stop the assembly language program, or whenever you want to stop the action of the processor, then you can make the use the instruction halt, HLT. So normally whenever we write any assembly language program, then at the end of the assembly language program, we write this instruction halt. So it will stop the processor 8085. So this is also a 1-byte instruction. Whenever we do not want to perform any operation, then in that case, you can make the use the instruction no operation, or NOP. So no operation will be performed. The register and flags are unaffected. This instruction is normally useful whenever we want to achieve some time delay in the timing loop. So whenever we want to have some time delay in the processing, then in that case, you can make the use of this instruction. This instruction is also a 1-byte instruction. So all of these instructions are very useful. And when we see how to write the programs for 8085 microprocessor, there you will find that we will be making the use of all these instructions in the assembly language program written for the different applications. So thank you, friends, for viewing the session. Hopefully you have understood what are the machine control instructions for the microprocessor 8085. In our next session, we will discuss how to write assembly language programs for the microprocessor 8085. Thank you all for viewing the session.